Okay, I did it. Let me check again. It's fine or still it's noise?
Yeah, it's fine now. It's fine now.
Okay, good. So, shall we start or wait for some time?
Yes, sir. You can start. I think they'll join. So we'll might
Fine.
late. We have to
So,
finish also on time. So okay, you
okay,
can start, sir. Once again,
okay,
welcome. You can take the stage and continue, sir. Thank you.
okay. Yeah, okay, good. So, good afternoon to all. So, hope all of you have a good lunch, and I will make sure that you don't sleep in this session. Okay, I will make it as an interactive session. So, let's start with the application layer protocol. So morning, I will revise again. I will say I'll take 2 minutes to revise. We learn about WSN, how IoT can, how, which are the problems in WSN, how IoT can resolve, then the logical design of the modes, and then architecture part. Then we go with the different the protocol stack, right? How it works, and then we already went through. Uh, the communication model, communication patterns, and the deployment strategy. So now let's start with uh, application layer protocol. So first protocol we call as a constraint application protocol. Okay. So what is the need of the designing of that? So in the first session, I already presented that the HTTP plus REST, right? So HTTP is a request response protocol, and which is already following the representation state transfer framework, right? So mainly people are using HTTP when they want to do some communication over the internet. And as we mainly see that HTTP works on top of TCP. Okay, HTTP works on top of TCP. So now the thing is that TCP is already have some of the functionalities. Like we can say that condition control, flow control, reliability, over error control, and many more. The segmentation, reassembly, everything the TCP can handle. So now only thing you can do while using HTTP is just handle the application efficiently, code efficiently. Now let's take an example. That my question is that whether should it be good, will it be good to use HTTP as it is in IoT network? Let's go through some example. Now, one of the example is that smartwatch. Right now, the everyday people are using the smartwatch. Okay. Now, what smartwatch is doing is there is a sensor beside that, which is called the heartbeat sensor. Right, the green light one, and it constantly reading it the heartbeat values. Maximum heartbeat value is 3 digits, right? If it is go above the limit, the person can die immediately, right? So the thing is that 3 digit value means 3 bit required. Okay, now let's take an example that you have a heartbeat, reading a heartbeat, and that heartbeat says data you have to send. Assume that you have to send those heartbeat data to your doctor so you can measure your continuously heartbeat. Okay, now the thing is that okay, now the thing is that suppose you use HTTP protocol, okay, to send the 3 bits data, right? The request has been raised by the doctor and you to sensors, and sensor is sending the 3 bits data to every time. Now you assume that you use HTTP protocol. So the main concern is that for HTTP protocol is use TCP as a transport layer. So main functionality of TCP is connection establishment first, then send the data, right? As many as data you have and close the connection. Now, most IoT traffic is periodic, right? That is not constant traffic, periodic traffic. So the thing is that it's not constant traffic. Now, suppose the doctor raise a request, right, through HTTP, and I am sending the data over HTTP response. Okay, now after that I have to wait for some time, right? It's not constantly sending again. So now if no data has to be sent, then you have to close the connection as per TCP requirement. now suppose Now suppose you have to, doctor has to raise the request again after few seconds. Okay, again the connection setup is there, close the, send the data. After again some, for some time I am not sending the data, close the connection. Now in per day, if doctor requests 1,000 requests or 100 requests, let's take and assume that 100 requests. So you have to open the connection 100 times and just send the 3 bits of data. Just send the 3 bits of data, you are sending it and just close the connection. See how much header is there, because you are using TCP, underlying transport. So your packet data, HTTP header plus TCP header plus your packet payload. So it oversize of packet you are sending right over the internet, and just for one few things, and again you are sending again for the thing. So the resource wastage is that because of this constant network, and you are again and again using it, right? It won't be feasible. They create an overhead in the network, too much overhead in the network. Again and again you are sending the data. Okay, that's not suitable. So the common scenario is that HTTP is not suitable for IoT because feature is required as a persistent connection, right? But the, whether it's suitable, IoT network require persistent connection? No, not at all. Only some of the application is required. Not all application require persistent connection. So why should we come up with HTTP? No, we need to find some another solution. And mostly the IoT network we call as a low power and lossy network. Low power, as I mentioned, that it's a resource constrained devices in terms of memory and power, as well as the wireless IoT network use wireless communication. So link disruption happen frequently, right? So if we use TCP, then every time open the connection, close the connection, and on top of that, if you are sending the packet, then TCP maintains states for every open connections. Whenever you open the connection, it maintains the state until you close the connection, right? And this behavior, if you are running on those tiny devices, the scenario, if you are running on tiny small devices, either you get that embedded device or IoT device, it becomes too heavy, right? Right. So the thing is that we need a lightweight protocol, application layer protocol, which has a similar functionality of HTTP, but it works, it easily fit on IoT device or network. Whether we have this type of protocol, yes, which is called the constrained application protocol. So constant application protocol is specially designed a lightweight application layer protocol which has a similar functionality like HTTP, but the main thing is that it runs on top of UDP, right? It runs on top of UDP. Now, it doesn't make sense that the researchers are already working on it. It can work on it, make it work to the with TCP too, but not as it is TCP, right? The researchers are already working to trim the functionality. Now, as per requirement of the application, you just trim the functionality of TCP and use some of them and make it suitable to work on lightweight devices. Okay, so this CoAP protocol is already standardized by IETF, which is RFC 7252. Okay, and it has a following the machine-to-machine communication similar to HTTP. And the main features are that it follows the asynchronous message exchanges. The header complexity and header is very low, right? I will explain the header part. Similar type of method, get, post, put, delete, anything. And CoAP supports 4 different types of messages: confirmable, non-confirmable, acknowledgement, and reset. So now the thing is that the question should come into the mind that yes, CoAP works on top of UDP, fine. But what about the reliability? How can I know that my packet is successfully delivered? Because TCP has a functionality that yes, your packet is delivered, you will get a response, good. But how can I make sure that if protocol like CoAP works on top of UDP and I'm sending the request, and how can I sure that my CoAP request is successfully delivered? Correct. So for that purpose, right, they integrated a message types. First is a confirmable message type. So application layer, they handle it. Reliability, they handle at the application layer. So what they handle is confirmable message through message type. So first message is confirmable. Confirmable means once devices send the confirmable message, the other server side has to respond it. Until you get the response, either packet dropped or not, right? The confirmable message is not a maturity. So if whether you want to achieve the reliability, you have to use the confirmable message type. Again, inside that, if you don't want to use reliability, some of the application don't need it. So you can go with the non-confirmable message type. Correct. In that, you can't get the reply. I will explain using the diagram. Acknowledgement is simple and reset is simple. So I will explain about the diagram so you can understand that. Now, if you're working with the CoAP consists of mainly two layers. First is a request response layer, which is directly handled with the applications, and another is the messaging layer. The messaging layer is directly handle the asynchronous messages with the UDP, right? So let's take an understanding of the confirmability. If you are very good about the HTTP, that is similar to that only. So client server applications, because the request response, so client is sending the confirmable message, right, with the preferred message ID. Server has to respond with the acknowledgement. If it is a confirmable, server has to respond with the acknowledgement with the same message ID, then it can match. But if the server having some problem, right, then it can send the reset messages with the reply, not acknowledgement. Right? Now suppose no, non-confirmable. Non-confirmable means you cannot achieve the reliability, your application doesn't need reliability. You can easily use the non-confirmable message easily, like it's like spray and wait. Spray, you don't have to wait for that. But in this you can't achieve the reliability, that is fine. Now, how the response layer works. Suppose the client is sending the confirmable message with the message ID to the server and asking for get the pressure value, right, with the token. Get the pressure value with the token ID. Now, server has to respond. Once the server get the request, it process the request, check that the server, it has a sensor with pressure. Yes, client is asking for the value. So what it will do, it will prepare the response acknowledgement in terms of acknowledgement with the same message ID, with the pressure value and with the token number, right? And this is called the piggyback response. If the response is sending within the acknowledgement, then it is called the piggyback response. Piggyback response. Correct. Now, suppose client is asking a get the pressure value, but server doesn't have a response ready. Whether it should wait for sending the acknowledgement, if it is not sending, then client has to wait for certain amount of time. It is not like constant waiting time, right? For certain amount of time it has to wait, which is called the retransmission timeout. Okay, RTO, retransmission timeout. It has to wait for a certain amount of time. If the acknowledgement doesn't get, then client has to, what it has to do, retransmit the packet, right? So suppose the server is busy, right, and server doesn't have a, still taking time to prepare the response, so it would be good to send the empty acknowledgement, right, the empty acknowledgement with the same message ID. Now suppose after a few minutes or few seconds, server is ready with the response. So server is ready with the response. So what it will do, it will send the confirmable message with the same message ID, sorry, confirmable message with the different message ID, with the value of the pressure, right, with the same token ID to the client side. Now client once receive this confirmable message, means either way, if client sending the confirmable, server has to acknowledge. If server has to send acknowledge confirmable, client has to acknowledge. So client will send the acknowledgement. Now the issue here comes with that, how this value the client can relate that which this value belongs to this which request. So for that purpose, the token ID is important. See here. Here you can see the token ID is it's similar. It's a piggyback response. But in this kind of scenario, which is called the separate response, okay, which is called as a separate response, right? The token ID is very important to matching the response, right? So this is the header format. So you can see that the coep version number, type of the message, the confirmable, non-confirmable. So coep version number is 2-bit. Type of the message is again 2-bit, either 0, 1, 2, right? So confirmable, non-confirmable, acknowledgement and reset. Token length, whatever token we are specifying, how much length is there, which is a 4-bit field. The code, the response code, like if you are already worked with the HTTP, you have some response code like 205. If error, client side error, then 400 series, server side error, then 500 series. Similar kind of functionality is here also. So they have a 4-bit length code field, sorry, 8-bit length code field, which in that you can use the response code, whether your packet is server successfully delivered or any error comes client side, server side. Different types of response codes are there. And last is a 16-bit is message ID. Okay, and then actual token carries actual token, and these are the options and payload are totally, if exists you can send. So to see, if we consider this header only, it is only 4 byte, right? 2 plus 2, 2 plus 2 plus 4, 4 plus 4 8, 8 plus 8 16, 16 plus 16 32, 32-bit means 4 byte. Okay, this is a very minimal header. It can easily fit into that, and these are my papers that I already worked with. My whole PhD thesis on this protocol, CoAP protocol. So this actual working of CoAP. Here you can see that actual working of CoAP. So if CoAP client is sending the confirmable message, so as per standards, it has to wait for certain amount of time, which is called the retransmission timeout. I already said 2 to 3 seconds. If the server is get send the acknowledgement within this limit, it is fine. If it is not like this, if it is not, right, then client will apply the binary exponential backoff method. It will double the RTO value and send it, right, until it will get the successful acknowledgement. But whether it will be sent infinite time, no. So they kept the limit that maximum 3 times retransmission can be done. This is first time, this is second time, one more time. If within 3 retransmission, if server doesn't reply, then that transaction considered as a failed one, and again it will start with the new confirmable message, send a confirmable message with resetting the value from 2 to 3 seconds. Here it is said, if 2 to 2 seconds, if we apply the BAB, it will double, again apply the BAB, double, again apply the DB, double the value, and at the end, if we are not getting response, it will reset the value. So there are certain disadvantage of this model. So the ITF and some several researchers come up with the new method, which is called the COCOA, the CoAP congestion control mechanism. Sorry, the CoAP, the congestion control mechanism, advanced congestion control mechanism. So what had happened in COCOA is that they apply the 2 phases. One is called the strong phase, and one is called the weak phase. Now, what is happening? One of the problem is here is that they are applying directly RTO, retransmission timeout. But if you follow the networking concept, retransmission timeout is calculated based on the RTT value. Here there is no RTT value. So what the researchers did is COCOA is also the internet draft, which is called the spelling. I will write in the chat so you can understand. COCOA is also a standardized, RF internet draft is there. It's still in the standardized process. What it will do is they divide the transaction into 2 phases. Suppose you get the acknowledgement in a very first attempt, right? It will consider as a strong phase. It will calculate the RTT. Based on the RTT, it will calculate the RTO, right, for strong, and it calculate the RTO for new transaction for the next. Now suppose if you send this, you are not getting the acknowledgement, or your request is dropped, or not getting the acknowledgement is dropped like this, then timeout occur, it will go to the retransmission phase, and retransmission phase, there is a called a weak phase, right? Weak RTT calculation, right? And instead of binary exponential backoff, they apply the variable backoff factor. Variable backoff factor means they have set the thresholds, right? It should be fit within the threshold. Okay, if your RTT is, or your RTT is less, so multiplication factor is large, so it will fit in the threshold. If RTT is large, multiplication factor is less, so it fit in the threshold. So main idea is that irrespective of RTT large and RTT small, you have to multiply with certain factor, right? So you kept the RTO in within the threshold limit. Okay, so it will calculate RTO, again RTO will calculated, RTO for the new transaction calculator. Likewise is going on. Okay, so this is the Cocoa one, and I have already worked with the both the algorithms and come up with a few more the solutions, efficient solutions which already deploy in the market also. Now I already explained about the protocol. Core protocol is this, core protocol is this. What about the implementation? Correct. So the thing is that there are several implementation of CoAP is available based on your expertise. Suppose you are good in Python, go with the Python framework. CoAP has a different type of framework. Based on that, you can choose. If you are good at Python, go with the Python framework. If you are good at Java, go with the Java framework. So if you are good at the Java, there is a Californian framework. For Java, right, they have a Californium framework. If you are good at C, they have a so many framework. One of the well-known framework is Erbium framework. Correct. Likewise, in Python, okay, you have a AIO CoAP framework is there. So there are various frameworks are available based on the expertise. So your programming language, so you can go to the particular site, you will find several frameworks. Now, this is about the CoAP. Okay, now about the MQTT. Okay, so MQTT is nothing but a message queue telemetry transport. Okay, so it's works on top of TCP. Okay, MQTT works on top of TCP. It's a lightweight messaging protocol, and works is it's a mobile to mobile communications. And ultimately you can see that there are several apps running on that, there are several sensor nodes, there are actor nodes, and applications are running, and all things are maintained by the broker. So here you can say that I already mentioned that the publisher has to publish on certain topics, message has to be published on certain topics, and it will go through the sub broker. Broker is maintain the topic dictionary or database inside that. Once subscriber subscribe to the particular topic, broker has a responsibility to send the notification or send the data on that particular topic to the subscriber. So this subscriber subscribe to 4 only, so it will send the 4. This subscriber subscribe to 1 and 2, so it will send to 1 and 2. This subscriber subscribes to 123, so it will send a notification to 123, right? So the complexity wise, MQTT is simple and low complexity, as well as the memory requirement is also low. And who built this? So there is a IBM and Eurotech, two industries are initially developed MQTT. Then it will be of official standard by the OSS, but still it's working on making a standardized, right? OS is already standardized, it's not like that, but the community like internet draft IETF, right, that standardized process is still required, no doubt, because it industry developed this product. Sorry, the IBM and Eurotech are industries, they develop this protocol. So OS is standardized, is always standardized, and many industries right now using the MQTT. Okay, so the latest version of MQTT is version 3.1.1, right? And the changes is that they restricted to the correct message now. Now, how it works? Because see here application, you are running the application, right? Where either temperature sensors or any application you are running, And here we can say that MQTT client. Client means nothing but we can call client as a publisher also, we can call client as a subscriber also. And they are directly communicating with the broker. We in terminology we call it a server. Again, the client server communications, right? But the main thing is here is that underlying network is TCP/IP network, correct? So the persistent connection you will get it because of TCP/IP. So once the session is maintained, right, between the client and server, publisher has to publish to server, and subscriber has to get the data from the server. Okay, so once the session is maintained, the publisher or client can easily communicate with the server, either it is publisher or subscriber. Now I already call that we call client as a publisher subscriber, broker is we call it a server, right? And certain topics is the maintain as a topic is nothing but the maintain of the queue message queue. Now this is the most important thing that you understand. There are two types of session, which is called that, or subscription session, which is called the transient, and one is called the transient, another one is called the durable. Now what happened between these two, right, is depend on what you can ask for in the during the connection setup. Okay, so you can see here subscription will be transient. Transient means for the per certain amount of time, not the constant, right? So now see, these are the messages M1, M2, M3, M4, M5, M6, and the session is maintained for particular time only, because once you open the connection and close the connection, the session is maintained the particular time period. So now suppose session is maintained for particular time period. On top of that, you are maintaining the subscription for particular time period. So if you are getting the messages constantly from here, right, in this period, these packets are dropped. In this period, these packets are dropped. So drop means directly dropped. You are not having this anything again, right? And once it start the subscription, you will get the new message. So what about the previous message? It will gone. You can't get Unity for that. But if you set the transient subscription, but if you set the durable subscription, right, durable subscription, what happened that subscription is durable, the longer period of time. Whether you are maintaining the sessions in the chunk wise, but once the message comes, right, it will be here only at subscription phase. Suppose the session is closed here, and in between the message 2 will come in here. Message 2 is coming here. What happened? It will land on this subscription phase. But you once you open the session, you can't get the packet. Once you open the session, at that time, first you will get this packet, and then after the new packet. Likewise here also. First you open the session, you will get M4 and M5 first, and then M6. So there is no packet loss, right? As well as the session created, new session start, you will get receiving the previous messages. So there is a difference between, this is a difference between transient subscription and durable subscription. In terms of diagram wise, you can see here, if you set up the transient subscription, TCP connection setup is done. You send a connect message with the clean session is equal to 1. You will get the connection acknowledgement. These are the message type. So here you can see the message type. So the message format here is again the for the 2 byte of header, 4 bits of message type. Message type is like 0 to 15. 4 bits is easily fine. Whether there is a duplicate message or not, for that purpose 1 bit. QoS level 0, 1, 2. What is the importance of QoS? I will explain. And whether you want to retain this message or not, right? So for that 1 bit. So total, and this is the remaining length. So 2 bits, 2 bytes of fixed header, not 4 byte, 2 byte only. So how much minimal or lightweight is that? Assume that. And the message type is like connect, connect acknowledgement, publish acknowledgement, publish received, REC means received, publish REL released, publish complete, subscribe acknowledgement, unsubscribe acknowledgement, ping request, ping response. It works like keep alive timer. Your server is not responding, just sending the ping request and you will get response. Server will on. Disconnect, and last bit is resolve. Okay, so now understand that once you send the this transient, The connection setup is done. You send the connect message with clean session 1. So the session lifetime will start. The connection acknowledgement you are getting, then you can subscribe to particular topic. The subscription lifetime will start once you send the unsubscription, right? You get the acknowledgement once you publish the message. Once you get the unsubscribe, the subscription is end, unsubscription is done, and disconnect. Once you send the disconnect, it will disconnect the session also. All right, this is called the transient, right? Here, durable. Once you session start, it will as long as connected. Once you send the disconnected, and subscription will start once you establish the connection. Not here it subscribe, then no. Once connection setup is done, at that time subscription lifetime will start. It will long enough, right? This session will be disconnected, but not subscription. This is called the durable. The message type. So one message type, now duplicate one bit, detect the packet is duplicate or not. QoS level, right? Here the assurance, like reliability, I said, right? This way, the assurance of that, just a minute, I will have a water. So you will get assurance of that, whether you want which type of assurance of the packet delivery. So whether you want to deliver at most once, which means no guarantee of delivery, you can set the QoS level 0. Whether you want to set at least once delivery, means acknowledgement is required, then you can set QoS level 1. Whether you want to set exactly once and each and every steps, you need a confirmation, then you can go with the QoS level 2. Right? And for retain 1 bit, you want to instruct the server that please retain the last message. Now let's understand that how it works. Suppose you already have an example of that. Suppose you are the publisher, I am the publisher, correct? And I will publish some data with return is equal to 1. If I am not maintaining the return is equal to 1, what happen, I will explain. So let's understand that I will explain the return is equal to 1 and data is sent. Okay. Now server is getting the data. It checked that return is equal to 1, means I have to cap the message, this published message. Now you are the subscriber. You subscribe to the server. You will get the published message immediately. Now some another person is that subscribe recently, right? Recently, so it will send the subscribe message. You will get he will get the acknowledgement also, and after that, because if the return is equal to 1, that means message is here only at server side. Okay, the thing is that now new subscriber comes, so server knows that the previous published message is written. So if new subscribers subscribe to this particular topic, then I have to send the data immediately. In common scenario, let me give you an example. Like we subscribed the YouTube channel recently, but we got a notification in our YouTube dashboard from 2 years back, 3 years back videos of the same channel. Why? Because they published the message in kept retaining 1. So once I subscribe today, you can see that you will see the notification of the videos of the same channel 2 years back, 3 years back. Correct. This is the thing of a retain. If I don't keep the retain is equal to 1, I don't kept it, the new subscriber won't get the new videos or new notifications. Nothing. They will get the new video, new data only, right? Not the old data. Okay. Now the QoS level. So QoS level is already explained. So suppose let me explain through example so you can understand that by properly diagram. So if I this is theory only, so I'm not going into theory, but I'm giving you the diagrammatically the pictorial way to represent it. So now QoS level 0 means fire and forget. You don't want assurance guarantee. So what you can do, client once sending publish the message with QoS 0, it itself delete the message. It won't keep it. Client won't keep it. Once server received it, subscriber to get the published finished. You can't get assurance in any phase. Once client publish, client deleted. Once server publish, server deleted. That's all. correct, which is called the QS level 0. QS level 1 means you need an acknowledgement, right? Whether its device is published or not. So once client send the publish, first it stored the message and then publish with the QS level 1. Once it's read to the server, server is also stored the message. It will publish the subscriber, and once it will reach to the subscriber, server will delete the message and send the acknowledgement of this publication, means publication is done to the subscriber. It will delete the, once the client will receive the public acknowledgement, client is delete the message. Until get the acknowledgement, client is not deleting the message. Until get the confirmation of publish to the message publication done to subscriber, server is also not get the message. This is called the QS level 1. If you want acknowledgement for your delivery, you can start it. QS level 2. See here, in QS level 2, each and every phase you will get a response, acknowledgement. Now client store the message, send with QS level 2, server stored the message, it's published. Once it received at the subscriber side, server is sent the message, publication received, publish, received. Now once it is received, now client side can send a notification, send a message that, okay, now I don't want it, like publish released. At that time only, server delete the message. Until server get the publish release from the client side, it won't delete the message. Once it received, right, server will delete the message, and then server will send the publication completion done, publish completion done, and then after this message, the client will delete the message, right? So see here, each and every phase you are getting a acknowledgement, correct? But the thing is that QS level 2 is most overhead protocol, because see here, one, two, three control messages are add on, right? So it's create overhead in the network. QS level 1 is mostly people are believing it, right? Now the ping request and ping response, like we have a keep alive timer, right? Suppose you are publishing some video, client publish something on the server side, right? But in between there is no data to send or publish. What it will do, the constantly the server will, the pinging request will be sent, right, from the client side, because server is not sending the response. So in reply to that, server is the response, yes, I am on, I am on, I am on, like this, right? Same will with the will messages. So in case of, suppose there is a situation like, uh, unexpectedly client can disconnect depending on the application, subscriber application, but unexpectedly suppose client disconnect the application, right, due to internet or something, right, the notification is not received at the client side. Okay, so there is a solution which is called the will message. In will message, right, if the client can is disconnected due to uncircumstances, then server sends a message on behalf of the client to all subscribers that whatever the will message that can send last will, it will use. This is called the will messages. And now we will go to the topic wise. Okay, so topic, there is a level which is called the uh, single level hierarchy, right? It's plus, or we call as a wild card or hash, the multi-level hierarchy. If there's a single level means, see here, building floor, two floors are there, blind stairs, sensors inside sensors, light and temperature is there. If I uses building floor one plus, that means building floor one plus means only one level, plus means single level, right? Either it go to the building floor one blinds, or either it will go to the building floor one sensors, correct? It won't go to the both. If you put plus here in between, like building plus sensors, then only option is there floor one sensors, and if floor two sensors are connected like this, then floor two sensors. It will go like that, the path. If you put hash, hash means wildcard all level, multi-level. So if you put building floor one hash, that means building floor one blinds also, building floor one sensors also, everyone, right? If you put has in the between, then also floor one building, floor one blinds, building floor one sensors, building floor two sensors, building floor two blinds, if connection is there hierarchy. So likewise, this is all about the coding standards in MQTT. Okay, so these are the two protocols that I want to explain, right? Now I will go to the demonstration part, so you will get an idea. So we have gone through the two protocol, CoAP and MQTT. Any question till now? I will pause for a take a pause for 5 minutes, and then I will start the demonstration. Any questions in between? Okay, Vaishal Rao raise a hand. Do you have any question? Vaishali Rao? Vaishali Rao, please unmute yourself and ask the question. You raise your hand. Vaishali? Okay. If you don't have, fine. Anyone from the audience, do you have any question regarding CoAP understanding or MQTT understanding? Okay, fine. If you don't have any questions, then let me try explain about the implementation. Now we are going with the implementation part. Okay, so there are multiple ways to do the implementation of CoAP and MQTT. What I will explain here is there is a we call as a Conti key, right? So Conti key is an operating system, okay, which used as a research purpose. Okay, mainly people are using it for research purpose to do the simulation and validation of the protocols. So let me go through the Contiki. So there are multiple ways. If you are beginner in the Contiki, there are three phases. Either you go with the built-in packages, which is called the instant Contiki, which is give you a package, VM package, which includes all the things. Okay, required number of packages, required number of softwares, all the things are inbuilt. Just you have to open that VM file using either VirtualBox or VMware Workstation. Kept it, finished. Another solution is that source code. If you are a good amount of doing, you want to do some research, okay, you go with the source code part. Source code part means you have to download the source code from that website, right? What we call the fixed standalone source code. Then what you can do is you can install the requisite packages inside that, right? And then after you can start implementing or just doing the implementation. Third one is the working on the live code, which is called the developer code, which is a GitHub. So you can pull the data from the GitHub repository, okay, clone it, and you have to make a script that uh, every Thursday or Friday or weekday or 3 day after every third day you have to clone the repository, because if you are cloning now and working on the top of that, and after few days they have added new features inside that and you are not integrating it, it might be that your problem your solution won't work, correct? So you have to do, when you are working with the developer version, you have to clone it continuously by creating the script. So it will fetch from the resources, the GitHub repository, and again clone it and integrate to there. So what we are doing as a beginner, I will explain about the instant Contiki. So let me share my screen again. So hope now it's visible that. So what I will do, I will, I already downloaded the instant Contiki. Okay, see, this is the instant Contiki 3.0, right? And inside that there is a VM file we call as wait a minute. This is file. See, VMX file is a window file. So now I will open the VMware workstation. Once you download the zip file instant config 3.0, right, and when you extract, you will get all the files here. Only a few files you will get inside that. One VMX file is there, and by using a VMware workstation or uh, that virtual box, you can create, right, virtual machine. I have created with 1 GB memory, 10 GB hard disks, unlimited. Now let me power on this virtual machine. I have upload the VMX file here, so it will work. Hope you know that how to create a VM. If any doubt on creating a VM, you can ask me right now once it is booted. So now once I will power on this virtual machine, what it will do, it will start the booting the VMX file. What VMX file contain? It contains the Ubuntu, it contains the Contiki, it contains the required package, all the things. It contains the software, jar file, environmental variable set, all the things are here. So Quantiki is nothing but we call as a operating IoT based operating systems, which is C programming base, right? Which is C based uh, operating system, and it supports so many things. All the protocols Quantiki supports. So as a research purpose, startingly it would be good if you can start with the instant Quantiki or Quantiki operating systems. Right now, once you load automatically, the by default password is user. Okay, the by default password is user. So I am entering the user password here and I will press enter. So once I press enter, it's like inbuilt system with Ubuntu. Okay, and you will get this dashboard type. Now, first you open it first time, right? It's Ubuntu 14.04. It's already outdated. So it will give you whether you want to upgrade the details. No. Please ask, either you say don't upgrade or ask me later. Please don't upgrade it, because once you upgrade it, some of the features can't work. Okay, and it require more space to install it. Right now it's 22 or 24 point something is going on, right? So it would be good if you don't update it. So I will say the ask me later. And now you have to go to the places and home folder. If you are going to the home folder, what will happen here? You will find the Contiki folder here. Not Contiki 3.0, because Contiki 3.0 is a zip file is there. So there is a call Contiki. Yeah. So you can start inside that Contiki. You can go and here you can find all the related things here. All the related things here, right? Whether in terms of protocol, whether in terms of routing per layer, whether in terms of application layer, all the things. There are various folders. I am just briefly explaining each and every folder. I am not going into the deep because it's a time consuming. Okay, and it required full day to give the demonstration of this proper all the protocols. So that's why I keep my limit to CoAP and MQTT, and I'm not going into the deep of that. So I'm just briefing it about each and every folder, so you can get an idea that which folder is what about that. And in the later, if you want to try it and you have some doubt, you can ask me. Again, one more thing, it will ask for software updater also. Please don't do it. Always say remind me later. Now, apps. The first folder in the Contiki apps. So inside app, you will find the various applications like email applications, like HTTP applications, FTP applications. If you're working in the co-app, there is a co-app application. So here, Contiki use RBM framework, right? RBM framework of co-app inside the Contiki. That's why they call as a ER co-app, right? Some telnet application. So each and every applications are here. So you can open it application, you can find the relative code here. Okay, I'm not going to the deep because it will take time. Again, the core part of the network, like which are the library, which are the developer, because Contiki supports the coffee file system. Contiki supports the coffee file system, which is short form is CFS. So they supports here, right? All the systems of coffee file system letter file is here. Then CTK file, development file, library, loader. If you're working on the network layer, So network layer failures like IP64, IPv6, IPv4, RPL protocol, as I said, the network layer, the contact means I have to use RPL. So RPL related code is here fully. Okay. Now, if you go to the CPU version, so in CPU you will find a processors MCU code. So like CC2538 series, CC2430 series, ARM based processors, right? Or MSP43 microcontroller. So all the related code of this MCU or processors are here in CPU folder. In development, again you are finding the development version of that. If you want to go with the certain docs or pics, you will find it here. Now, Contiki will give you some pre-built examples. So if you want to start some basics, you will start with some basics of pre-built examples. So it will directly work. Okay, like a hello world program is there. Okay, FTP example is there. Okay, and you can create your own application also. Okay, and several other examples. If you're working with the CoAP, right? They have a ER REST example. Okay, because CoAP is a request response protocol and request response following the REST framework. So ER REST example is for CoAP. So several basic example that now there is a MQTT SN example is already there. Platform means nothing but a board because you are doing a simulation. So the thing is that you are creating a mode. So you are creating a mode, you have to upload the firmware on top of that, right? So for that they use all the inbuilt modes like Raven board is there, right? Kuja board is there, CC2.38 board is there, like device. Sky mode is there, Z1 mode is there. So all the modes, right? And their codes. So what inside that? Their code, actual code, like architecture code, configuration code, how it works in Contiki, how it works in the platform works, which are the parameter has to be set. All the codes are here for that particular mode. So you can find in the platform, and some testing is there, some tools are there, inbuilt tool that will help you to analyze the data. Okay, and several other things are there. Now, main thing is that Contiki supports have one simulator which is called the Kuja simulator, Contiki base, which is a Java based simulator. Okay, and it can easily simulate you things. So what you can do is you have to open the terminal here. Okay, hope the fonts are visible to you, and you have to go to the Contiki first. So I will go to the path cd Contiki tools Kuja. So inside the tools Kuja is there. See, inside the tools uh, Kuja. This is simulator. So if you open the simulator, you will find that Java being this. If you want dist file, you will find the jar file. So this is a jar file. We have to compile and open the simulator. So let me open. Sorry, not here. So I will go to that path Kuja, and now to compile it, I have to use sudo ant. Ant is a one package that will compile the jar file. So if I type sudo ant jar, it will ask me the password. Now password is same, user. Okay. Once you press after entering the password, if you send enter, it will compile all the file. Okay. Now the thing at the end, if you get the message build successful, right? That means correct. If you are getting some error here, right? Like package missing or something, then you have to resolve that error, install that package, and then work on it. Now the compilation is done. Now what we will do is we will run this. So for run, we have to do sudo and run. Once you press run, your Kuja simulator will open. It will compile the jar file and the Kuja simulator will open. Hope it's visible to you. If it is not visible, just let me know. It's visible, right? All of you are sleeping or what? The session is getting bored, sir, all of you? No one is replying. Okay. Okay, fine. Thanks for letting me know. So now here, if you go to the file, there are several tabs, right? If you go to the file, you have to create a new simulation, right? And if you have an existing simulation, you can open it. So if you existing simulation is there, then it has an extension is .csc. Okay, you have to open that file. So if you go to the example, several examples are there. Let me open it. If you go to the several examples, correct, let's that hello world. So you will find here csc file. See, hello world app.csc. This is the file. Correct. This is a simulated file, and right, it will show same simulators. Once you open it with the Kuja, it will directly open a simulation. Okay, so let's create a new simulation. So once you create a new simulation, click on new. It will ask the simulation name. So I will get a demo triple IT Sri City. I'm giving the name triple IT City. Now the radio medium. Here they are radio different radio medium. One is the UDGM unit disk graph medium, which is based on distance loss. Another is UDGM based on the constant loss. So what is the difference between these two is it's a radio environment. One is distance loss means once your node is far away from that node, another node means it is not in the communication range of that node, right? So it is based on the distance the packet has to be delivered or not successfully. It will decide. Next is the constant loss. In constant loss, what happened that it fixed amount of loss is there, whether you the transmission range or not. Okay, so there are two types of range: transmission range and interference range. If the node is in transmission range, and then the packet has to be transmit. If node is in interference range, means it can interfere the other network. Okay, so constant loss means fixed amount of loss is there, directed data, and the like in hardware also, right? It takes some to boot up. Setup, so we get 1,000 seconds and the random state. Now if you're running the simulation, you can aware that we don't say that only one run, we run the simulation only one time and say that my algorithm works. No, we have to run the and multiple times and then take the average of that. Correct. So for if you run the multiple time, it may be possible that you will get the same amount, same values. So if you change the random seed frequently, okay, your chances of getting the new value will be get higher. And if you say tick mark this means on every reload, once you reload it, right, a new random seed generated and you will do the simulations. So let me create a simulation now. Once you click on create, this is the happen. Okay, so what happened here is down, it is called the timeline. Timeline means it will show the radio traffic of all the modes which you develop, right? This is the network part where you can deploy your nodes. This is simulation control. You can control the simulation like start, stop, reload, and set the speed limit also. And there's a node. You can specify the node at for which purpose you want to do. So I can specify that co-app demo for triple IT CTC CCT participants. Correct. So this notes, you can save it or you want to close, and there's a mode output. Now you are running the simulations. You have include some printf statements inside that or something. So that printf statement should be printed here, and later you can save the file or you are running multiple times, right? So you can first you can save the file and next times you can append to the file same file again and again. So you will get one big file. So you uh, uh, that will be easy for you to do the manipulation. Okay, so now what we are doing is, let me explain by using some diagram if possible. Here it's possible or not. Let me check. Mm, no, it's not there. Hmm. So what we are doing here, okay, we are creating a one network. Okay, please bear with my drawing. Okay, so inside that network, we deploy one several nodes. What our application is, what happened? Okay, fine, close it. Our application is client server. Okay, with the CoAP protocol. Okay, client server application with the CoAP protocol. So our client is running somewhere else, right? And here we are deploying some server nodes. Okay, some server nodes we are deploying. Now, if client wants to communicate to this server nodes, right, how it will work? Whether the client will directly communicate to the network because it's outside of the network? No. Clear answer is no. What we have to do is we have to put something in between, right? So the client can communicate to this node and this node through this node. They are communicating to the server. Okay. So this is called the gateway or which is called the router, right? We place as a border the border router. So what the example is that we deploy some servers and border router here, and through outside the client we are communicating to the servers. We are getting the resource representation or the values of the sensors from this server. Okay, this is a normal scenario that we are doing it into this example. So any doubt from the audience till now? So I can start the simulation part. So hope you understand this scenario, because if I will do it right, then you can ask me the question. This is the scenario we are explaining it. We are doing it. So now I am doing it. See, I will deploy some modes. So if you want to deploy, you have to go to the modes, add modes, create modes, and I'm selecting one type of mode. Let's check sky modes. Here I will place the border router. Okay, and now I will set, go to the code. Where is the border router code? Inside the conti key. Go to the examples, then IPv6, then RPL border router, because routing has to be done through RPL only. As I said, I will select the C file. Once I click the open, you will find the compile and see, understand this code. So whenever you are working with real type of mode, you have to type command like make, then whatever file name you want to give, which is output file name. Okay, output file name here. Output file name is border router.ski. If you don't want to give, it's optional. You can, and then you have to set right target is equal to, when you are working with the real modes, target is equal to type of mode that you want to with extension. So this is the common scenario. Make is compulsory, then border router dot sky is optional name. Then which type of target you want to do. Here I am selecting the sky modes. Target equal to sky automatically come, and then see the create button is disabled. Once I'll compile, it will compile the whole C file, right? And what is successfully compiled, the create button is enabled, and then you can create, click on create. It will ask them how many number of modes you want. So you can select the one mode. If you want to set the positioning, you can change the positioning and add modes. Now you can see here, right? I will change the mode type also. See, once I click on the mode, you will find the two colors. One is green color, one is gray color. So gray color means it's a green color means it's a transmission range. Gray color means it's an interference range. Okay. So if the node is in transmission range, means data has to be sent. If the node is in interference range, means it has to interfere in the network. Now I will create the server. So as per this, I am creating the server. So border router is done. Now I'm creating the server part. So I will go to the sky modes. Again, let me check. I will say the CoAP server. In CoAP server, I already said there is an example called ER REST, because CoAP works on REST framework, REST, and I will select the, where is the server file? No, server.c, ER example server.c. Optional target is equal to sky. I will compile. Once it is compiled, this is a red color, is called the warning size, right? It's fine. If it is an error, then it can't enable the create button. Okay, so I will create, now I will create the three modes, three servers, and I will choose linear positioning. See here. Okay, let's see how it works. Linear positioning and add modes. See, all are linearly aligned. And if you select the node, you will find the transmission interference range. Now, no node is are connected to each other, right? So now we have to create the topology. So what I will do is, it's a drag and drop, right? It's movable. So I will select like this. I will select here. Now I will create a two number node. See, 100% is come here. See, it's not 100%. See the one number. See the here, the percentage will come. So now if I select the two number, see it coming 100%, right? Now I will say the three number is in range of two. What I will is in direct, 2 and 4 number are in direct communication, the transmission range of node number 1. Node number 2 is in transmission range of 4 and, sorry, transmission range of 1 and 3, but in interference range of 4. 4 is in transmission range of 1, but interference range of 2. So this is a scenario. Right. Now, as per this is client cannot communicate directly to the server. We need to open a bridge in between. Through bridge. Correct. So what I will do is here, to create a bridge, I will right click on this, go to the mode tools, and I will go the serial socket server. So now serial socket server is created. I will start the bridge. Okay. So here see the radio environment is created in timeline. So in timeline, you can find some color packet, blue, red, green. Okay. So if it is a red packet, means that packet is dropped. Blue means send. If you see the green packet, means it's received. Okay. So see now, this is not a capable. You have to open the bridge also. So what I will do, I will go to the Contiki example IPv6 RPL border router, and here I will connect my router to the Kuja simulator, because router I put, if I connect the router to the Kuja simulator, at that time the bridge will open. So I will press enter. Again it will ask password, same password, user. Now it's waiting for connection bridge to be open. So once I will set the speed limit to 100. Once I click on start, you will see here the IP address comes. Now bridge is open perfectly. So now client can communicate to the server directly. So here you can see that it works. I already said that it works on IPv6 addressing schemes. So if start with a letter A or BBBB like that, then it will be a local address, local host, we can say that. And if it is FE80 starting with, then it is called link local IPv6. There's too much deep inside that. I'm not going into the deep of that. For that, I have to tell you the IPv6 addressing schemes. It requires time. So now bridge is open. I will keep my limit up to this only. Now bridge is open, and here you can see that each and every device is booted. See, first server is booted, started with this address, this MAC address is this, null security is that, MAC address is this, the radio duty cycling is null. Now we didn't set anything, and clock, the channel rate is 120 hertz, channel number 26, threshold minus 55, and starting the server. Same way, 4 number started, 1 number started, 3 number is also started, and it is waiting for the response, right? And you can see that the number of bytes from socket to mode to socket is done. And here you can see some of the things. Now let me open one tool, right? So that I can uh, check with the radio messages. Okay, so there is one tool called radio messages. In radio messages, once you create the radio messages, inside that analyzer you have a 6 low pan analyzer with pcap. So now you can generate the pcap also and verify your packet with Wireshark. So I can generate the pcap, so I can verify the letter with the Wireshark. Now to done with this, to communicate with this, I have to open the client application. So where is the client application? In application, go to the internet, and the browser, Firefox is there. So inside Firefox, you will find one application which is called the Erbium. Sorry, Copper plugin. Okay, so Copper plugin is there. See here, CU Copper plugin, which is by default there. Install the once you install the instant Contiki, it will get Copper co-op user agent, right? You will find. So now let's understand the topology. Here I create a topology, but whether it's perfectly set or not, so to verify that, I have to write HTTP, and what I have to write is server's IP address, border router's IP address. So I will take this IP address, okay, and in the browser, I will paste it and close it, okay, and I will done. So see, the Contiki RPL run. See here, Contiki RPL is comes, and you can find that the direct neighbors is border routers. Direct neighbor is 4 and 2. Check here, it's perfectly there. Border routers direct neighbor is 214, correct, and 3 has to be passed the message to 2. Okay, so 3 has to pass the message to true. Yes, perfectly topology is set up. Now we are sending the request. We are sending the request. So instead of HTTP, what we are writing is a coap. Okay, bracket. Okay, and what we are writing, the IP address of that. Now how to I find the IP address? So you can find the IP address of the nodes from here. Go to the view, IP address and scheme. So here you can find that FE80. See, FE80212740333303. It's a link local, but we are working on the local host only. We are not working on the link local. So instead of FE80, what we have to type is 4 times A. So if 4 times A, then 212.7402.2202, and the port number of CoAP is 5683. But when you are working with CoAP S, the chat box, once I will press enter, you can find the particular things. Dashboard will open with the get, post, put, delete messages, and this things, sensors, actuators, and some part is there. Likewise, let's say the node number 3 is there or not, perfectly working or not. Okay, let me check with the node number 3. Okay, 3 is also working. Let me check the node number 4. Okay, node number 4 is also working, correct. So now I will check. First I will send the request that I want to ask the server how many resources do you have. So I will click on core, well-known core, so it will send the request like that. Okay, and I will set the get. Once I will click get, I will get in text format. Push messages are there with periodic demo, and in actuator I have a red LED, not any other LED but red LED. Similarly, in node number 3 I can try. Okay, similar type of that. In node number 4 also I can try similar type of that. So what I can do is I will change the LED color of node number 2. So for that, I will open, I will just IP address. I will open the LED of node number 2. Sky 2 is there. I will open the LED. So here you can see that red, green and blue LED, but they mentioned that I have only red LED. So what I will do is I will give the toggle, click on toggle. I will go to the outgoing message because incoming is already one, nothing. So I will go out and mode is off. So I will make a on. Mode is on. And I will send the post request. I will change the condition of the LED. So I will make a post. Yes, successfully 2.05 content. So message code 2.05 and RTT is 1077. RTT of this dashboard. And you can see here LED is on. So I'm changing the resource right now. Again, I will click on right instead of off on. I will send the off post. It will off. Correct. Now I will send for node number 3. What I will do? Hello. If I hello and I will get see hello world reply is getting. Okay. Now let outgoing method is not allowed. So in push method is not allowed. Let me type some data and I will put is also not allowed. Okay. So let me check something is fishy here. Yeah. So push is not working right now, but hello should work. Yes. Correct. Node number 4. So you can see that each and every node, a server node is accessible through outside the simulator. So copper is connected to that and you will find here through the bridge. Now let's verify that whether we are getting the CoAP packet or not. Through here you can verify message to socket to mode and mode to socket. Almost equivalent packets are there. But I want to verify that whether I'm getting or not. So I will go to the Contiki tools. Then I will go to the Kuja. I will go to the build and here one pickup is generated. What is the properties of this pickup? 13 December. Yes, right now. So I will open this pickup. Meanwhile, I will pause the simulation topology here. See, several messages are there. It will create the topology. Now, Wireshark support the CoAP. So if I click on CoAP, write CoAP and presenter, will send the data. See the data. First, I will send the confirmable from this to node. You will find the 6LoWPAN is also there here, compression. And in the CoAP, here you will find the version type is 1, confirmable type, and count, get message sending. And if you check the payload, well-known core. So here down. See here, well-known core. If I change, let me check the LED one. Here, well-known core is also there. See, hello world. Now, so you can see that this is the acknowledgement type. Okay. And 1, 2, and if you see the payload is a hello world. Correct. So likewise, you can verify that CoAP is properly supported by the CoAP and this is the client server applications we already did, right? Any doubt? Do you have any doubt to the CoAP? You can here I create the client is outside and server is inside. You can also create the client server application inside that only. For that, you have to specify the IP address of the server in the client code so it can directly communicate. So now if let me show you the MQTT example. Okay. So let me switch on this. If time permits, then I can show you the MQTT example in Contiki also. So MQTT example is in my local setup, not in the this one. Okay, let me increase the font size. So hope it's visible to you, all of you. It's visible, or shall I increase? So now it's visible. Okay. So what I will do here, we already installed the Mosquito publisher and client. So Mosquito is a browser, sorry, broker. Mosquito is a broker. I already installed, and they have a publisher and subscription, the code, subscription code also. I have already installed the clients and Mosquito clients we call. If you are good at Python, you will go to the PAHO, right? PAHO is a good, the broker communication is also there with the PAHO client and PAHO publisher and PAHO subscriber, which is all totally Python based. So what here I will do is I will run the Mosquito here, right? Which is already in use. So let me create. So if you are getting this messages, it's fine. If not, then you have to directly the server will run. So it will run on the 1883. If you are running this with the port number 1883 is easily done. So let me check here how it works. I will check the status of the Mosquito service. It will take time. Wait a minute. It's running right, and PID is 1254. So let me kill this PID 1254. Okay, I already killed. Now let me start again server. So now see, my Mosquito is running. Mosquito broker is started running. Now what I will do is I will publish the message. Okay, first I will start the server. Okay, so what I will do, I will subscriber. Okay, so I will subscribe Mosquito underscore subscribe. T means topic XYZ, port number 1883. Okay, so let me press enter. So now subscription is done. Now I will open another terminal and I will publish something here. So if I published Mosquito publish here instead of topic XYZ, if I change the topic PQR, okay, PQR. So topic name PQR message hello port number 1883, and I will check that it will publish or not. It's published, but server is not getting any response here. Here you can see that you will get the connection acknowledgement, connection is done, particular type, right? And this connection is done because the server is why? Because the topic name is not matched. The subscriber subscribe to the topic XYZ, but publisher is publishing on PQR. How it will receive? So if I will change the topic name to XYZ and I press enter, and you can see that hello you are getting message because I print hello. Now I will change the hello triple IT Sri City participants. Okay, I published triple IT Sri City participants. I'm getting it, and here you can see the messages. See that just recall the PPT. The connection new client connected. it will get the acknowledgement, we are publishing, and then after disconnected. And by default, which QoS level they use? QoS level 0. QoS level 0. I didn't set anything. So by default, QoS level 0. If you want to set, you want to set here only. QoS level 1. Okay. So still I have let. So this is a example. Broker is running here, and you will see the message ports and all the things code here also. The MQTT protocol also detect this what we call the packet drop also, and Wireshark also detect this packet MQTT, right? Subscriber topic. This through Mosquito, it is perfectly done. So I'm not closing it. Any doubt till now? Any doubt till now? Now here I will show the MQTT demo. Okay. So I will create a border router again. Any doubt you can ask me right now or put in the chat box. Uh, uh, Bhimappa sir? Uh, so it will work as a publisher subscriber. Let me put into the range. I have a separate router inside that. Mm, So I have go to this folder, Contiki, MQTT, SN, example tools, Mosquito, RMB, RSMB source. And here now I will run one command. Huh. That broker MQTT right? Configure MQTT. It will ask the password. So now my broker is started running here. And let me start the simulation here. So the MQTT protocol already started here, and bridging is already started, and you can see here they are already register the find and subscribe, connect, all the things here you can find. See, there's an automatic code. The running is already there. Okay, so subscription is done particularly upon particular point of time. The packet is already sending by few of the subscriber. Okay, so subscription is done, registration is done, connect message is sent, and you can find here all the things with. So this MQTT example is also you can done. Any doubt till now, because this is the way you can run the MQTT example also. Okay, here you can see the one type the connection is done again. 1 2 3 4 5 6 7, the registration is done. Node number 3 register, and then it will subscribe to the topic. So it's constantly running on. Okay, so that's, and from the my side, two more protocols are there, which is called. Let me stop presenting here. So two more protocols are there that I'm not covering in detail. One is called the DDS, right? DDS means data distribution service, which is mainly use a brokerless protocol, which use a publish subscribe base. Okay, let me write a name here. DDS, data distribution services, which is a brokerless publish subscribe protocol, which is widely used for data distribution services. Sorry, it automatically got disconnected. So widely used for brokerless, the data distribution service, the database part, and another protocol which is called the AMQP that I am mentioning is again the broker pet queue. You can maintain all the thing exchanges and other. For that you can go to the one of the site which is called the rabbit mq site for AMQP, which is have a good things. All the things are in the rabbit mq are python based, so you can do the experimentation on top of that using the rabbit mq. Okay, in DDS we don't need because mainly the database handling part, so there is no protocol. You can use the xmpp part protocol, it is fine. One of the main thing is that I want to show you is let me share you. Niyapa sir,
Yes, sir.
shall I
I'm
take
here.
2 minutes? 2 minutes more,
I think
if you have.
I did not hear you. Can you? Hello,
Uh,
sir.
can I take 2 minutes?
Hello.
Can I
I'm
take
audible to
more?
you? Yes, sir. Sure, sir. You can take more.
Am I
Yes,
audible?
yes.
Yeah. So let me share the screens. 2 minutes, not more than that. I will take. So once
Sure, sir.
website is there, you can go through that website if you are starting with Contiki. Okay, which is my screen is visible. My screen is now it's visible. One is that the website is that which is called the USC. Wait, anrg.usc.edu/Contiki. So if you open this website, it is taking too much time. Our internet connection is not proper. So this is the website. You can note it down: anrg.contiki.usc.edu. Now it opens. See, anrg.usc.edu/contiki. Inside that Contiki tutorials, you can click. You will find the from installation to create your own application. All the code examples, all the things are here for starting purpose. You can start with this and see in IoT. Simulation is not a good thing. Even if you do the simulation and research and do the publish the paper, no one is except you run on real time test bed. So there are two test bed. I don't have that much time, so I am not covering it, but I will write a name. You can go through that. It's open source test bed, right? You can use as many as time. You can run the algorithms, all the things there, right, properly. It has supports the Contiki. It has supports the Riot operating systems, all the things. One is test bed is called the FETA RT Lab, which is in France, and another one is called the Flock Lab, which is in Zurich, Switzerland. So these two testbed are open source and anyone can use it. Just register yourself and do the experimentation, take the results, do the analytics, and very good tools, right? My all the algorithms I have tested on FitRT Lab, so it will be good to start. So yes, that's end from my side. Any questions from the audience or anything?
Audience, if you have any questions, please let us know. Rathod sir is waiting. So
Any OS? Okay, so both are operating system. I'm not saying that Tiny OS is not a, but the thing is that Tiny OS is now outdated. Okay, and there doesn't have a one simulator is there. Okay, and that is also now not supported. And IoT perspective, Tiny OS doesn't have anything. So I think 2014 onwards, Tiny OS doesn't have anything. So they stopped the supports. Now they move on to the Contiki. So Contiki is specially designed for IoT-based applications. All the protocols, all the things you can find it. If you go to the Tiny OS, no. Even the simulator they have, they don't. I think they don't have a GUI-based simulator, right? Contiki have a GUI-based simulator. You can work on top of that. No doubt the file system may be different, right? And Contic is still, I think, till 2021 or 2022, they have a support, right? They didn't have a support after 2023 onwards. How to keep next question? Hope I'm able to answer this question of how Contic is different from Tiny OS, right? In terms of memory and all the things that the difference is there. Now, next question by Dr. Sumulata is there how to keep our auto device safe from interrupt attacks and any architecture protocol suggestion is there? Yes, so there is a attacks, it's possible. Okay, to keep it safe you have to implement the secure boot, because right now I am working on IoT security. So we are working on the lightweight encryption decryption algorithms like ascon, uh, is used for the spelling of ascon is this, which is already standardized by NIST, and you have to do the encryption decryption. Whenever you are doing the transmission, you have to use ascon, do the encryption decryption as well as hashing, right? You can use the ecdha dsa to generate the sign the your packet. You can use ecdh inside the IoT environment to generate the public private keys. Okay, and main thing is that a secure boot, it is very important when you are working with that. So all the things club together and you can make a secure communication. Hope am I able to answer your question, Dr. Subalata? Okay, thank you. Any more questions from audience? So for OS differences, there is one paper which is called the IoT operating systems comparison, right? I think a paper is there. Let me see. I will put a link here so you can understand that what is the difference between different OS. Just give me 1 second. Any other questions from the audience? Till now, till I will
no,
put
sir.
something here.
There is one more question, sir. Sumalata, you can ask.
I already gave an answer of that.
I think
One more question. Can hacked OS, what is it?
Active OS is some OS, I think. Hacked OS.
Hacked OS. I didn't what heard the name. Can you elaborate more about this? What is it? What is it? So there is a paper. You can go through that. The different OSs are there. Oh, not working. It's a kind of OS. It's a React OS is there. Riot is there. No, it is a Riot. Riot or FreeRTOS. It's a free RTOS, sorry, RTOS, not Riot and FreeRTOS. These two systems, two operating systems are used for embedded, which is called as embedded operating systems, which is we call as embedded operating systems that we use. FreeRTOS and RTOS, RIoT. These two are used in the embedded systems. Hacked iOS, HACKET, I didn't heard the name. So thanks for letting me know so I can go through that. Because I am in embedded domain, we use the embedded device, we build the secure operating systems, right? Embedded operating systems. Inside that, we use the Linux distribution and integrate the security. We can use the free RTOS also, right? No, I didn't heard the name hacked OS. I heard the tiny OS, but I didn't heard the name. Sorry. I think you are talking about hacked OS means you are talking about the hacking of the communication protocol, because I didn't. Okay, okay, fine. There are several mechanisms to hacking the communication protocol, right? To secure it, we have to work on it. Hacked OS is one of the part of that, but I didn't heard of it. Sorry to say that. We are working on different methodology. We are securing the transmission which are going through the UART. So UART transmission is secure, UART port is secure, SPI port is secure. All we are making secure. We are not using any kind of that hacked OS part. So I'm not aware about that. Okay, thank you. Anything else?
Okay, I think there are no questions, sir.
Okay, fine.
Yes, Dr. Vishal sir, once again, special thanks to you for taking two sessions with the hands-on. So I think it was much more useful and matched our workshop theme, right? So I once again special thanks to you for sharing all the knowledge and experience in IoT use of IoT applications, especially with
Yeah,
respect to
so
communication
thank you
and
very much,
practical
Bhiyapa
action.
sir, for
Thank you, sir.
inviting me. Thank you very much, Bhiyapa sir, inviting me. If you have any doubt, you can contact on my
Anyway,
mail ID.
we'll share this recording, sir, in our website and PPT to students.
Yeah, you
It'll be
can
very-
find me on LinkedIn, or my mail ID is there. So you can find it. I will put my mail ID in the chat box. You
Sure,
can
sir.
note it down. If you have any doubt, you can ask me there. And if you want to know more detail, the discussion about the each and every protocol with hands-on embedded system simulations, UART, SPI based simulations, security based simulations, you can contact me anytime.
Okay, sir. Thank you,
Okay,
sir.
this is my mail ID. Okay, thank you very much.
Yeah,
Thank you.
bye.
Bye bye. Good day to all. Bye bye.
Bye, sir.